Today, on how it's made. Wax figures. Awnings. Sandwich crackers. And pewter tankards. We can't all rub shoulders with political greats and movie stars, but for the price of admission to a wax attraction, anyone can mingle with their wax replicas. These lookalikes aren't much for conversation, but the likeness can be startling, thanks to a process honed over centuries. Famous faces come to life in beeswax, so it's almost like seeing them in the flesh. But how do they do it? It often starts with a face-to-face meeting with the subject, during which they take over 200 measurements of the face alone, and still more of the body. Drawing on those measurements, and using photos and additional research, an artist sculpts a clay body onto a metal skeleton. This clay sculpture will be used to make a mold. The head, of course, receives special attention. They sculpt it in stages, and this takes about 6 weeks. To check the symmetry of the sculptured face, the artist stretches a wire from the temple to the chin. She measures it from all angles and compares the numbers to measurements of the actual subject. Every single aspect of the clay face must mirror that of the subject's precisely, so if it's even slightly off, she makes adjustments. Here, she redefines the teeth a bit more. And then she tweaks the hairline. They're now ready for the next step, the making of the head mold. The worker paints plaster onto the sculpture in 14 different sections. This multi-part mold can be easily removed from the clay head once the plaster dries. After the clay head has been discarded, they give the reassembled mold a quick rinse. The wax artist turns the plaster head mold upside down and slots it into the wax bench, so named because it secures the mold during the wax casting. They melt blocks of Japanese beeswax and funnel the liquid wax into the neck of the plaster cast. They let it set for an hour, just long enough for the wax to solidify and form a thick crust around the inside of the cast. The artist removes crust at the neck and pours out the rest of the wax, leaving a hollow wax face inside. They set it aside for another hour to further solidify. The wax artist removes the plaster mold and comes face to face with the wax creation. She examines it thoroughly, confirming that the detail from the mold has been effectively transferred to the wax, and that the wax face is a dead ringer for the human subject. The team then casts the wax figure's hands, and an artist matches the subject's skin tone against a chart. She mixes paint and dabs the brush in it. She then strikes her brush with another one, so the paint splatters across the hand. She blots up the paint to blend it in. This technique gives the wax a speckled look that mimics human pores. She paints on knuckles, veins, and distinctive markings to mimic those on the subject's hands. She gives the nails a manicure to make the hands look identical to the subject's. In the hands of a skilled artist, these wax hands have come to life. As a medical glass eye spins, the artist blots on a very wide pupil first, and then paints the periphery to mimic the person's iris. Iris color and pattern are unique to the individual, and the artist replicates those qualities as closely as possible. She glues red silk threads onto the whites of the eyes to simulate broken blood vessels. It's another touch of realism. They slot the eyes into sockets in the wax head. Then the wax figure is ready for its hair, actual human hair matched to the subject's. They pierce the wax with a hot needle to insert each hair individually. The wax melts and closes around the hair. This process can take 4 weeks. They also plug in brows and lashes, and then brush on paint like makeup. With his face on, the wax figure now looks true to life. Once completed, wax figures get movie star treatment. Their hair is washed and styled regularly, and their clothing is routinely dry cleaned. After all, even wax versions of famous people have to keep up appearances. The unfurling of awnings usually marks the rollout of patio season. It's a long tradition, one that actually dates back centuries. Early Romans were among the first to seek refuge from the hot sun under fabric awnings. And today, design innovations mean there's always something new under the sun. With modern mechanisms, unfolding an awning has never been easier. This manual crank system is designed for a smooth rollout. And for extra convenience, there are motorized awnings, operated by remote control. Production begins with the fabric, which comes in a range of weather-resistant synthetics. The seamstress cuts out patterns from thick acrylic material and sews the pieces together. Here she works on the awning's front valance. A roller keeps the fabric correctly aligned and stops it from bunching up as she sews. She stitches a long pocket along the border. A plastic rod will later be channeled through it to connect the valance to the awning framework. She traces a scalloped edge onto the bottom of the valance and then carefully cuts along the penciled line. With a steady hand, she follows the outline precisely to give the valance those distinctive curves and notches. Workers then position the awning panel in front of an aluminum tube. They thread the pocketed end of the awning into a channel in the tube and then slide a plastic rod into the pocket. This secures the end of the fabric to the tube. It takes 2 people to avoid any buckling of the fabric. They insert a plastic cap into one end of the tube, but leave the other end open for the installation of the motor. They now wind the awning panel around the tube, synchronizing their efforts so the tension in the roll is equal at both ends. Next, rollers carry a squared aluminum tube to a circular saw. Once in position, arms descend to steady the tube, and the saw slices it to the correct length. The cut tube will be the carrier bar, an important part of the awning framework. A worker now builds that framework, starting with the carrier bar. He slides a bracket partway down the tube and uses it to attach the retractable arms, securing the assembly with a heavy-duty steel pin. 2 workers slide connector pieces into grooves in the drop bar for the valance. Then they raise the bar and attach the retractable arms. They install a side bearing in the end of the connector bar. It's one of 2 that will support the awning's main tube. Next up is that fabric-wrapped tube. They attach it to the framework and tuck the other end of the awning fabric into a round slot in the drop bar. They slide another long plastic rod through a pocket in the fabric to secure it. They're now ready for the motor. It's a tubular model. He attaches a metal bracket for assembling the motor to the main framework. He then equips the tubular motor with 2 plastic rings, one at each end. Powered by the motor, these rings will revolve to open and close the awning. A test confirms that it's fully operational. He slides the tubular motor into the open end of the awning tube. He attaches the second side bearing to the metal bracket and caps the open end of the drop bar. A few taps with the hammer drives it down the shaft. He now tests the awning to confirm that everything unfolds as it should. He tightens some screws, and when it's perfectly operational, he'll install the valance. It takes about an hour to manufacture a motorized awning, and it should supply about a decade of shade. Sandwich crackers are one of life's little conveniences. Crispy wafers with peanut butter or cheese spread between them, all wrapped up in a neat package. In North America, factories have been mass-producing these snacks since the early part of the 20th century to satisfy the need to nibble. Sandwich crackers come in handy for a quick refuel. Just unwrap and snack while continuing on your routine. They start with the smaller ingredients for the dough, which include baking soda, a powdered cheese additive, and a kind of phosphate, which, like the baking soda, is a leavening agent. Next are enzyme tablets and yeast, 2 ingredients that will later cause the dough to ferment to give the crackers textural strength. They add water and thicken the liquefied blend with a little flour. This makes it easier to pump into the next mixer. This one is a big trough full of flour. They add ice to chill it and then pipe in the small ingredient blend. Cooling the mix with ice preserves the yeast and enzymes to hold off on fermentation. If fermentation happens too soon, the dough could turn to mush. They lower a lid equipped with 3 spiraling blades and set the blades in motion, pumping in more water to augment the moisture from the melting ice and small ingredient blend. It's now ready for fermentation, so it's into a warm room to activate the yeast and the enzymes. The dough swells, and a worker breaks the crust to release gas. An automated system tips the trough of dough into a chute that takes it 1 floor down to the rolling station. The chemical changes caused by fermentation have made this dough less sticky, so it can now be rolled into sheets without adhering to the equipment. The dough now travels between rollers that flatten it and squeeze it to a specific thickness. The sheets of dough exit and accumulate. When several layers have piled up, the dough is on the move again. Several layers at a time now, it moves between a series of rollers which compress the dough to its final thickness. A quick dust with flour, and the dough now goes under a rolling cutter, which scores it to cracker-sized proportions. The cutter is also spiked with pins that puncture the dough. The holes give the crackers a dimpled look, and they have a practical purpose, allowing steam to escape during cooking for a crispier snack. A sprinkle of salt, and the cracker dough now heads into the oven. This oven is over 60 meters long, with several heating zones. The hottest is around 370 degrees Celsius. A roller breaks them cleanly along the score lines. A quick spray with vegetable oil adds flavor. The crackers then transfer from one conveyor to another and land in neat stacks. They head into an inspection station where workers pick out any damaged crackers and adjust the alignment of the shingled rows so it's a smooth transition as the crackers move into lanes. Down the line, workers pull off samples to weigh them. Then equipment flips the crackers upright, positioning them to enter the filling line. The peanut butter filling is ready and kept warm so it's smooth and creamy enough to pump. The top crackers now head downward in a precise configuration, while below, the bottom crackers whiz by the peanut butter depositor. It pumps a dollop of peanut butter onto each bottom cracker. The peanut butter-covered bottom crackers now move forward to meet up with the top crackers. And again, with perfect timing, the top crackers land on the bottom ones in exact alignment. Equipment separates them into sets of 3 as they head into packaging. Plastic wrap envelops them, and a heat sealer cuts and closes the packets. Suctioning arms collect the packets and transfer them to cardboard boxes. From mixing to packaging, it's taken about 24 hours to produce a packet of sandwich crackers. Once it reaches a hungry snacker, it'll be gone in no time at all. A traditional drinking vessel typically used for beer, a tankard often has a hinged lid you raise and lower with a thumb lever. Dating back to 15th century England, they were initially made of wood, then silver or pewter. The tradition of handcrafting pewter tankards continues today. This manufacturer makes pewter tankards in many styles, one of which has the legend of the King's shilling engraved on it, and a reproduction of a shilling coin from 1816 encased in the glass bottom. Every step is done by hand, beginning with a sheet of pewter that's just more than a millimeter thick. Using a punch press, they cut it into the shape required to form the tankard's body. Next, they place the pewter on a copper plate, which has on it, in raised lettering, the story of the King's shilling. They feed this in between 2 rollers, which press the lettering into the pewter. A soft metal, pewter is composed mostly of tin, along with smaller quantities of 2 other metals, antimony and copper. Next, a metalsmith takes over. He manually bends the pewter into the cylindrical shape of the tankard's body. He brushes on flux, a chemical which helps molten metal flow more easily. Then, with a soldering tool, he fuses the edges of the body with pure tin solder. Traditionally, both the pewter and solder contained lead, but today, both are lead-free. Next, the metalsmith slides the cylinder onto a steel form and hammers the solder seam flat, rendering it virtually invisible. Now, a specialized tradesman known as a pewter spinner slips the body onto a lathe. As the lathe rotates, he uses a series of tools to smooth the surface, trim excess off the top and bottom, and turn the top edge over to form a lip. Next, A buffer uses pumice and a cloth buffing wheel to remove imperfections and make the surface silky smooth. Meanwhile, in the casting department, they heat solid pewter to 240 degrees Celsius, then carefully pour the now molten metal into a rubber mold. Inside are several cavities for shillings and large rings. After about 30 seconds, the pewter solidifies and the parts can come out. To make the tankard's handle, the casters pour molten pewter into a steel mold, then tilt the mold in all directions to spread the rapidly setting metal all along the wall of the cavity. This makes the handle hollow and therefore lightweight. They grind the ends on an abrasive belt, so the handle will fit flush against the tankard body. Another worker, meanwhile, assembles the tankard's glass base, a glass disc, a shilling, a ring, then a second glass disc. The ring acts as a spacer, creating enough of a gap between the glass discs to allow the coin to slide around. He applies waterproof glue around the perimeter to adhere everything together. Next, he places this shilling sandwich in a pewter base and adheres a second ring to hide the glue. Back to the metalsmith now. He dabs the tankard's body onto a pad impregnated with flux. He then solders together the body and base. Once the parts are attached, a final buffing with a soft felt wheel. Next, the metalsmith dips the handle ends in flux and solders them to the body. To avoid scorching the tankard surface, this time he uses a bismuth and tin solder, which requires a lower temperature to melt. The tankard is now fully constructed. They clean it in a dishwasher. Then they shine it up. First, the polisher does the inside using a rough grit abrasive compound, producing a matte finish. Then he polishes the outside using a finer grit compound. This produces a contrasting mirror finish. In 18th and 19th century England, a volunteer for army or naval service accepted a shilling as a bonus upon signing up. However, volunteers were in short supply, so recruiters are said to have visited pubs and slipped shillings into the pewter tankards of inebriated men who, upon their last sip, discovered they'd been duped into serving. It may well be a myth, but it still makes a darn good story to share over a pint.